So this is the third semester of the introductory physics sequence, physics with calculus 2220. There's two sections merged here. So if you're in the honors section, then you'll have some additional, maybe somewhat deeper problems to work on, homeworks and exams. Usually those are extra credit for those who aren't in the honors section. And otherwise, there's the same lectures and so forth. I'm Dr. Daw. And this subject this course will, we're going to talk about waves and also mostly atomic physics. So that's the topic for the main topic for this semester is quantum mechanics. And this class is usually quantum light. This is not going to be quantum light. You're going to learn quantum mechanics in this class. And you've probably heard a lot about quantum mechanics. Some of you did an assignment where you're looking in the popular press. If you actually start searching for articles in the popular press, you'll find something every day about quantum craziness or something. And in recent years, there has been a lot of confusion and craziness about quantum mechanics, but there's been a lot of work on the forefront that has resolved a lot of this. But unfortunately, and as you'll understand in this book, you'll understand the modern way of understanding quantum mechanics, the proper way. So you'll get that in this class. And later in the class, I may talk to you some about the articles that have been published in the professional journals that have come about. But these advances take time to soak in. And so they're not in the textbooks for the most part. There's two books that have this proper understanding of quantum mechanics. One is a book at the graduate level by Leslie Valentine. The other one is this book that we're going to use in this class. It's the third volume of the series called Physics for Realists. It's Physics for Realist Quantum Mechanics. And that's what I'll use in this class. So this is the textbook. How many have not yet gotten their book? A half dozen. Okay, have you made arrangements to get the book? Okay. Because the bookstore, they usually don't order, they never order enough copies. So they may be out. You know, there any left? If you can't find it in the bookstore, I can send you a link where you can order it from the publisher directly. You have to pay shipping. Then if you get it through the bookstore, I guess there's not shipping, but they'll, it's slower. It won't come directly to you.
I got mine on Amazon.
Really?
Yeah.
Okay.
Go to the university library.
Yeah, there are copies in the library. But so price on Amazon was less than 150, I guess, from the publisher, I think.
I think I paid like, I'm on Amazon Prime, so I got free shipping too, but I was on 100.
Excellent. That's really good.
It was enough.
Okay. Excellent. That's really good. Yeah. Okay. Then you got the third volume, the one that the text, the cover looks like
and
this.
If anyone does get on Amazon, be careful because there's a lot of different ones.
Yeah.
I had to sift through it to make sure I was getting that.
Right. There's 3 volumes.
Yeah.
We're using the third volume. And also there are some used copies. This is a new book. There are not a lot of used copies, but the used copies are going for outrageous prices.
Yeah.
$800 or something. It's just insane. I don't know who's buying it. Don't buy it for $800. You can get it from the publisher. So this is my third time teaching this course from the book. It's that old, about 3 years old, 4 years old. And you're going to be among the first students to receive this modern understanding of quantum mechanics. It was written by Dr. Anthony Rizzi, who was on the LIGO team. Do you know about LIGO? Yeah. Gravitational waves produced by black hole mergers or neutron star mergers or neutron star with a black hole, that kind of stuff. It produces gravitational waves. These were predicted by Einstein's general theory of relativity 100 years ago. And in 2017 or 2016, 2017, they were discovered, and the team they awarded it to the leaders of the team, the top 3 guys. Really exciting stuff. So Dr. Rizzi worked on the LIGO. This is the part down in Louisiana, near Walker, Louisiana, outside of Baton Rouge. And so He worked on that. He was a senior scientist at the Louisiana site for some time. So he knows what he's doing. And he's written these books, textbooks, and I think they're just outstanding. And I'm going to start to introduce you to this today. It would be really great if you had had the other two preceding courses, mechanics and electricity and magnetism. Some of you had the E&M. Nobody had the mechanics, unfortunately. So now we have Professor Podilla, who's going to teach the mechanics starting this term. Hey, come on in. Wow, it's good. Come on in. Okay, so some logistics first. A lot of stuff on Canvas. It's all under files on Canvas. Even the syllabus is not under syllabus. It's under files. Everything's under files. There's a copy of the preface. So those of you who haven't gotten your book yet, I have scanned copies of the readings for the first couple of weeks. So it shouldn't be a problem, providing that you've got a copy coming. I don't have any problems with using the scans, right? I think that's fine. There's going to be assignments for each chapter in Canvas under the chapters. And there's a schedule of assignments as well in Canvas. You'll have homework due every day, every class day. Right now, I'm letting Canvas collect all of that. If things settle down, I would like to be able to just do it by hand. You know, you turn it in, put it here, and then I take it and I grade it. But for now, you'll turn it in on Canvas, scan it, upload it. One PDF file, please, for each person. Makes it a lot easier for me to do it. I'll email out solutions right after class. So you'll turn it in and get solutions. And then I'll grade it on Canvas, I'll mark on it, and I'll turn it back to you. So mark your homework, like the first homework for chapter 3 is 3.1. So mark it on there so I can keep track of each one of them, and they're all, you'll see when on the schedule when each one is due. So the homework grade is it's very simple. It's either a 0 or a 1 or a half, maybe. So 0, you just didn't do it. 1, it looks like you put in a reasonable effort. If I give you a 1, it doesn't mean that it's right. It just means that it looks like you put in a reasonable effort. It's your responsibility to go study the solution. I'll pick problems on the homework to grade. I won't grade the whole thing. So I'll pick particular ones that I'm going to pay attention to, but you should go study the whole solution and understand if your answer is right or not. That's your responsibility. A half is, well, you did not a very good job. Doesn't look like you really tried. Missed some really important stuff. Sometimes I'll let you try it over, and in which case you have a chance to get all your homework grades to 100% of the homework. And there's some extra credit always on many of the homework problems, so you can get more than 100% on the homework grade. So after I grade them, I don't know if you get notified, but anyway, you can go and see my comments on there. So, okay, so there's a homework due Friday. See the assignment sheet. So go to Canvas, pull up the schedule of assignments. And the first homework will be 0.1. So we're starting with chapter 0. We're not going to start with the book. I'm going to give you some basics that you haven't had. Basic physics that you haven't had yet. Okay. And so the first 3 days, I think, is chapter 0, just review of basic physics. Then we'll go to chapter 1, and then we'll have chapter M, which is also not in the book, which is going to be some math. So we're going to learn complex variables, Fourier series, Fourier transforms. And then we'll get into chapter 2. And that's where chapter 2 has a lot of meat in it, but it uses complex variables because that's standard in quantum mechanics. The Schrodinger equation is a complex value equation. So we'll use complex variables. Okay, so your homework for Friday is H0.1. And so you go into chapter 0 folder and you'll see the assignments for chapter 0. Okay, I love to have office hours, but right now I'm not sure when they're going to be. And I encourage you, if you want to see me, drop me an email and we'll figure out how to get together. The best thing is if you can come into my office, you've got a question, I'll give you a piece of chalk and have you work problems on the board, because that's the best way for you to learn. You get immediate feedback. So I like doing that. Short of that, if we're going to meet by Zoom, if you can have a tablet that you can write on so I can watch it, you can share your screen. That works pretty good too. Or you could just take a whiteboard, even a small whiteboard like you have in the kitchen, just a small whiteboard, hold it up to the webcam. That's not bad. Or even a piece of paper, but it's got to be a dark pen so it'll show up on the camera, okay? But I want to see you writing stuff, working out equations. Usually that's going to be the most benefit if we can do that. Unfortunately for this semester, okay, so office hours to be arranged. Drop me an email, daw@clemson.edu. This semester you don't have Thursday evening slot that you register for. The first 2 semesters you had a Thursday evening slot that was for common exams. I would use it before the pandemic to do recitations, and maybe we'll get to that, but you don't have, the problem is that you didn't register for a Thursday evening time slot. So there probably aren't going to be any recitations, and which is unfortunate because you could really learn a lot by that kind of interaction. But so whatever is received in the mode of the receiver. So I'm the sender and you're the receiver. And whatever is going to be received by you is going to be proper to your own mode of understanding, which means, of course, that you have to think about how you're open to learning. One of the challenges of this book, and it is a challenging book to read because there aren't any examples. The typical physics student pick up a typical physics book and kind of skim through the chapter, and then you get to the problems at the end. And then you start trying to work a problem and you go back to find an example that matches that pattern, right? Have you done that? Of course, everybody's done that because that's the way the books are written for that. You don't really read the text. It's not meant to be read. This book is meant to be read. He wants to engage your intellect and your understanding. You're not just the apprentice who learns how to copy examples and redo them. You're going to understand about what you're doing. That's the goal of this class. To put you in the role of the scientist, not just the calculator, but the scientist who does calculations. So you get to do the math. In fact, it's high-level math. But that's not the goal here. That's not the only goal. So reading is very important. And so you're not used to reading a book like this. It's really written to engage your intellect. This book is probably very different than any book you've ever read. It's very dense. If you have problems with it, try reading out loud. I know it sounds kind of strange. Try reading it out loud because it slows you down. And don't assume you know things. If there's certain things that look kind of familiar, don't assume that it's really familiar. Read it anyway and go slow. Don't skim. So you can't skim this book. You got to read it. It's very wordy with a reason. He's using words to connect to your intellect, right? So a lot of words, a lot of equations, but there are a lot of words describing the meaning of the equations. So you got to read it carefully. Got to keep up with the homework. Don't get behind. Homework every class. Don't get behind. It's just, it'll build up. Trust the textbook. It is really an excellent book. In fact, I say there's an infinite difference between this and other books. Infinite because he really is trying to engage your intellect to help you to understand what you're doing and not just teaching you kind of steps that you learn how to do, tasks that you learn how to carry out. Understanding is hard to test. It's much easier for me to test that you can do a series of tasks. That's again why those tests are just a series of tasks. It's easier on the teacher, right? So I'm challenged to not only to convey an intellectual understanding to you, but also then to see if you got it. And it's going to be challenging for both of us. Okay, ask questions. I love people who ask good questions. Ask any question. Okay, so how is this course different? And why is the book series called Physics for Realists? Okay, so here's a good question. What is momentum? So some of you had me in the spring, and so we've been through this. So I'd like to ask this question of those who did not have me in the spring. Yes, sir. Please remind me your name.
Silva.
Mr. Silva.
I know the equation for it is mass times velocity.
Right, P equals mv, right? Okay. Now, that's what you've been taught, and that's about as deep as it goes.
It's the energy pushing something.
Like energy stored, that's not energy, that's energy squared, but it doesn't relate to energy.
Yeah. Are you satisfied with that answer? You're still working on it, I think, right?
Well, energy is energy squared, I know.
That's another equation.
That's a unit.
So you're going to call it energy, but then you give me another equation for energy.
I'm just asking if it's related.
It is. But that doesn't really answer what it is, right? It's related to something else which you haven't defined except by an equation. Did you have something you want to try?
It's the energy that pushes things.
You're getting warmer. It's still bad, but it's warmer. Thank you for playing. It's really, you're trying.
If energy is energy squared and momentum is mv, then
Yeah.
how could they be directly?
I'll answer the question here in a minute. I've got a very good answer for you. You'll see here in a minute. Yes, sir, Mr. Patel.
Just speed and direction over the distance.
Speed and direction over a distance. Okay. You're lukewarm, not really getting any better. But isn't this a problem? I mean, does this make you squirm a little bit? If you've had physics before, most of you are physics majors, not all of you, but most of you are, but you're interested in understanding physics and doing it well. So why can't you do this? It's a simple question, right? So I'm going to give you the answer. It's very simple. But most people answer with an equation. If they've had physics, high school physics, college physics, they give you an equation. You can tell somebody who's had physics because they answer it with an equation, right? That's not satisfactory. So here is the correct understanding of momentum. And it's all packed in. I'll have to unpack it for you. But it's related to what's called impetus, which is the cause of locomotion. So momentum is the measure of impetus, which is the cause of locomotion. So let me explain that here. But I'll explain this. But I want you to see the difference between an equation first understanding, which comes out when you ask a simple what is question, and a physics first understanding, which is it's the cause of it makes things move. It's the cause of motion. Very different sort of approach. Now, the equations are essential to modern physics. They're an essential part of modern physics, and you'll understand how that works in more detail here. But what is lacking in almost all physics textbooks is this physics first understanding upon which the equations can build and make sense. So instead of just memorizing equations, you understand them better, you retain them better. And when you're trying to get into things that you're less familiar with, you have some feeling about how to proceed. You become the master, not just the apprentice, right? The apprenticeship is the apprenticeship of the equations. You learn how to do those. Then you come up to something new and you stop because the apprentice never really understands what he's doing. The master does. And so I'm trying to make you masters of the subject, not just apprentices. So that's this course in a nutshell. Yes, sir.
So,
Mr. Silva.
Yeah.
Thank you.
Momentum is the cause of motion.
Yeah, I'll explain here. It's coming. It's coming. We're going to do this. The equations exist. Where do equations exist? Only in the mind. I can write it on the board, but I'm just scratching symbols on the board. You have a conception of the meaning of the equation that's in your mind. That's where it exists. But where does the cause exist? In the things, in physical things. That's what you're talking about physics first. You want to understand what exists and how does it work? What does it do? And so that's physics first. Cause and effect is a physics first understanding. Okay, so I'll give you the explanation here about it. Momentum and impetus is coming, but I wanted to just get you to see where this course is going. The basic idea is you're going to put physics first, but it doesn't mean you don't get to do the equations. The equational is an essential part of modern physics. And we'll talk more about the character of modern physics as opposed to what preceded modern physics and the nature of that. So putting physics first will help you to be a better physicist, a lot better. It's an infinite difference to understand what you're doing than to just keep cranking. Okay. Oh, I'm sorry. The heck? It may. Okay, good. All right, so, but I'm going to tell you what impetus is and what momentum is, but we got to go backwards a little bit before we get to that. And this is some of the basics that you're going to learn. So let's go back. It's got to take a step back. We got to start at the beginning. Where is the beginning? It's got to be really simple. Not an equation. That's not the place you begin. You started understanding the physical world when your senses started becoming active. In your mother's womb, you started hearing and seeing things. You're a physicist right at that point. You're starting to study the physical world. So what is physics? It's the study of physical things, physical world. And that already, so this is a handout. You're going to get this off of Canvas. You're going to go through these things for your homework for Friday. What's in italics you're going to memorize. There's some amount of memorization here. Memorization is not the end. It's not the goal of learning. Memorization is an aid because a lot of this stuff is unfamiliar to you and it's pretty deep, but it's simple. And memorizing it will help you. You can recall it to mind and chew on it because you'll digest it that way. You're kind of like a cow that way. You keep burping up the food and chewing on it some more and then you swallow it back, right? So you're going to digest it by turning it over in your mind. You have it memorized correctly, then you can play it correctly and not get confused because part of the problem is misunderstanding. So memorization helps to avoid some of that. Okay, so what is a physical thing? A physical thing is something and can become something else. That's the essence of physics, is the study of changeable things. That's the meaning of the word physica from the Greek, the ancient Greek. Aristotle and others at that time were studying changeable things. And the designation for that general field was physics. It's translated into physics in English. So a physical thing is something and can become something else. It is and can become. It's both. That's an important thing. So how do you know physical things? Well, you know them through your senses. I mean, that's pretty obvious, but yes, sir. Okay, let me remind me your name. Cam. Yes, sir. Thank you.
Aren't there physical things that can become something else? I mean, like,
Are there physical things that cannot become something else?
yeah,
No. That's the definition of a physical thing. Can you give me an example of what you might be thinking of?
like energy. I mean, energy can go from like heat to
Right, so it changes.
and that kind of thing, but ultimately it's always energy.
No, it changes, right? It is changing.
It's changing its form, but it's still different.
No, it's not the same. So we'll talk about that. Energy, we'll start going more primitive. You weren't really, when you started talking about energy, was when you're much older. A child doesn't have the same meaning to energy. So let's talk about really primitive things like color and shape and size, those things. And we'll get to energy. But energy changes. Physical things, you know, a body, one body, this body could have energy, it gives it to another body, you know, so these things are changeable. They don't have to change all the time, but they can change, and they will change. And everything, every physical thing comes into being as the result of another change. It comes from some other physical thing. Okay?
I'm talking about energy changeable.
Yes.
So like, you know how there's like normal matter, like particles, like your
Okay, I want to hold your question for a second. Ask me a question about some simple thing that you know that's in this room that you can point to and talk about. This is physics, basic physics, right? I'm getting questions about stuff that you don't really know very well. I want to get questions about ordinary, common, everyday stuff. Okay, that's where we're beginning. So that you've got some concepts that are up high somewhere, floating up in the air, and you don't really know what they are. And what I'm trying to do is to go back to the ground and build the building from the ground up, and not try to build something starting up in the sky. And it's hard because you've not done it that way before, but that's where we're going. We're going back to the very ground level. We're going to ground physics in the real world. And math will come out of this. It'll grow organically out of the subject.
I can't talk about like how matter can be referred to energy, right? Water.
Have you ever seen that? Have you ever seen antimatter? Do you have any experience with it? You have to start with what you know and grow towards what you don't know. So you got to start with common, ordinary, everyday things. And let's go from there. So that's what I'm talking about today. This basic physics is really simple stuff that way. It's almost common sense, but it's made rigorous. But it starts with your common sense experience of the world. Everybody has this. There's no special knowledge required. Okay, so we'll get to other things like antimatter and all that stuff, but you got to start here. You don't really understand antimatter, is what I'm telling you, because you haven't really connected it to this stuff that you really do know. Okay, so in other words, you know a lot, but it's not what you thought you knew. What you know is the stuff around you. That's what you really know. And the other things that you have in your head, you've been told about, but you don't really know them very well. Like atoms, that things are made of atoms. Do you know that? You've been told that. I don't doubt it. I don't have serious doubt about it, but I recognize that that's been based on authority. Somebody's told me this. And I have a sequence of steps that I could take to confirm that for myself personally, to know that this thing is made up of tiny little parts, really small, right? But you guys haven't done it either, right? So this is, let's go back to the beginning and ground it in the stuff we know. Okay, so there are two kinds of knowledge of physical things. Sensorial knowledge, which is just, you see it, you feel it, you touch it, you taste it, pick it, you do stuff with it, right? But there's another kind of knowledge which separates us from the other animals, which is called intellectual knowledge. So sense knowledge is of particular things. Intellectual knowledge is something more, it's general. It's not particular. So I know coldness, or I understand locomotion, or I know the principle of causality, or I have other physics principles. Those are general. They apply to everything, not just particulars. Physics is general. It's not just that particular cannonball, but all of them, right? Everything is being shot out of a cannon. That's what we're studying. We want to understand the general principles behind something. But the intellectual knowledge begins with the sense knowledge. For us, there's no way around it. So we have to start with our senses, and everything that comes into the intellect comes through the senses. There's no bypassing. And that's an important thing to recognize. Everything you've learned was first in your senses. Okay. So physics, for that reason, physics is the base of all of our knowing and our thinking. That might surprise you. And it surprised me the first time I heard it, but it's true. And I can prove it to you. I can demonstrate it to you. It's going to take longer to do than we have in this class to prove some of these things to you. I'm planting seeds, and we can talk about them later. Some of the basics we're going to carry over. We're studying other things. But physics is the base of all our knowing, because what you know are physical things. And we think that way. We think in terms of physical things. We think that way. We explain things that way. Now, I'll show you how this works when we get to math, for example. Math comes out of physics. It's not something that just kind of comes into your brain like the dew fall. You learn math from physical things. Okay, so what's important in this, again, is this relationship between the general and the particular, or between the generic and the specific. So there's a lot of things in this class about general to specific. So color is general. You've never seen a general color. You've only seen particular colors. Okay, so there's a generic and a specific. Red is a specific color, but you understand that it's a color, and it's different than a taste. Right? These are things you understand. Okay, so this is the way we're going to explain things, like answering the question about momentum, which I haven't done yet. We're getting to it. The way you're going to understand things and learn how to understand them is to go from the general to the specific. So I'll start to answer a question like, what is momentum? And I'll start with the most general aspect of it, and then I'll make it specific. So we are rational animals. We're animals, that's the generic. What distinguishes us from other animals is our ability to reason. That's the specific. We're both. Both exist in us. The intellect and the animal. We're both. We're not separate. So that will be true. So all of the things that you're going to learn in the basic physics, the answers to these basic questions, we'll start with this general and move to the specific. Okay, so here are the first principles of physics. And in fact, they are the first principles of everything you know. Physics is the grounding. It's not the equational physics. That's not what I'm talking about here. It's the understanding of nature. Okay, the first principle. I can't prove any of these things to you. When I tell you what they mean, you'll say, oh yeah, right, okay, I learned that when I was a child. These are just statements of things you know, but probably have never heard them stated clearly. But I can't prove them to you except by just got to live in the world for a while and you'll know this stuff. But we got to start somewhere, and so that's what we start with. Very first principle is that things exist. I can't prove it to you. And if you question that, if you seriously doubt that you know that things exist, then you can't really do science. You have to presume this to do science, even if it's not explicit. It's implicit. Things change. Okay, remember physical things? A physical thing is something and can become something else. So physical things exist and they can change. Okay. Like the principles of grammar. You can't derive the principles of grammar. I can state them, what they are. You begin the subject of grammar by laying out the principles. You don't prove that words exist. You're studying grammar, right? Okay, principle of non-contradiction. Something cannot be and not be in the same way at the same time. Now, you may have learned that in logic. The principle, if you've taken a course on logic, this is the first principle of logic. Something can't be both true and false, for example. But before it's a principle of logic, remember I said everything you know comes through the senses and through the physics, through physical things. Before it's a principle of logic, it's a physics principle. It's a principle, a statement about nature, existence. I can't be both here and there at the same time. Okay, so that's kind of that. You have to parse that sentence because it's kind of long. It's got kind of looks a little complex. Just take it apart. Something can't just be this way and that way at the same time, same way. Principle of causality. Nothing changes itself. If you see something that's changing, you look for a cause. What caused that change? But the thing itself can't change itself, so you have to look for something else. Now, it's important in this sentence to know the subject and the object have to be exactly the same. In fact, I guess I would rewrite this as something cannot change itself, and then the subject is something, and the itself is the object of the sentence. That has to be precisely the same thing. Okay, so sometimes when I introduce this, somebody will say, well, I can change myself. I can change where I am.
And actually, I'll go as well, too.
Say again?
Like, if nothing can change itself, like, there would have to be a first change that would cause everything else to change.
Yes.
I know it's very philosophical, but still.
Okay, was there another question? Okay. All right, so why is it that what I just said, that I can move myself from here to here, why doesn't that conflict with, contradict the principle of causality? Remember, the something has to be precisely the same as the itself. So what changed?
Your position.
My place. I changed place. Did my place change my place? What changed my place? My legs. Pushed against the floor, changed my place. Okay, so then you understand it. You have to understand these things. They're very simply stated, but they're very, very precise. They've been hammered on for hundreds of years. They're very, very precise. Okay, the last one is important. Physical things exist either as a substance or as a property of a substance. Okay, so properties you probably kind of understand, but let's be rigorous about this. A substance is something that exists by itself. A property exists of a substance. Okay, how about red? Is it a property or a substance? You don't see red. You see something that is red. It's the color of something. It's the color of a substance. It's a cloth or something, paint. How about dog? Is that a property or a substance? It's a substance. It exists by itself. It has properties, like where it is, it's there, and it's so big, and it's so much, it has fur, and it's got some color. Those are properties of the substance. Okay, this is really basic stuff, right? But it's childlike, and if you think about it, this just confirms and makes rigorous those things that you knew when you were growing up. But you've never heard any of this discussed in this way before. Okay, so water is a substance. Lump is not lump, something else. I gotta fix that. Height is a property. Color is a property. Temperature, hardness, a lot of things like that are properties. Okay, so we can collect the different properties into various categories, and there are 9 of them. And there is a mnemonic to help you remember these. So the 9 are, here are the letters Q, Q, R, A, R, E, P, O, E, T. If you say it together, it says QQ Rare Poet. And I promise you'll remember that until you graduate from Clemson, maybe beyond. QQ Rare Poet. Okay, the first 2, and these, all of the properties that you can talk about substances, physical things, will fit somewhere in this list. So the first 2 are called intrinsic, and they have to do with just the substance by itself. The other 7 have to do with relations between substances. Somehow 2 substances are involved in some way, maybe more. Okay, so the first 2, quantity and quality. So we can talk about properties of a substance, just the substance by itself. And we put them into 2 big categories. Well, the first one's actually not big. The second one is big. Quantity is very simple. Quantity is extension and having parts. That's the proper understanding of quantity. Quantity is every physical thing has extension and parts. Pull it apart. You have lots of parts and you have extension. That's quantity. It's not yet number, and it's not yet math, and it's not yet measurement, not yet. This is base property of all physical things. And it's the base because you can't have the other properties without having the extension. So let's look at the second category. Yes, ma'am.
Okay, so like going back to properties,
Yeah.
like the color red,
Yeah.
like the way there's like a certain wavelength that creates.
Okay, wait. I'm gonna stop you there. Did you hear what you did? Do you know wavelength or do you know color? You should go back to the PS5. You didn't talk about wavelengths when you were 3 or 4 years old. You said red. Okay, so can you start without the wavelength? Can you just talk about the color? You don't see the wavelength.
No, you see the thing that has the color, right?
And you can't have color unless you've got extension, unless you've got size. You got no size, there's no color. Okay, so that's why quantity is basic and quality depends on quantity. So quantity is the base, called the base property of physical things. Because you can't have temperature, you can't have hardness, you can't have all these other things unless you've got something extended that they can be in. If it has none of that, if it's got no extension, then there's no other properties. So that's the sense in which quantity is called base property, the physical sense. So quality is huge, lots of qualities. And just about everything you can say about the thing, physical thing, by itself that isn't quantity is going to be quality. So like I said, color, texture, hardness, all of these things. Your ability to know is a quality of you. Power that you have. You can understand. That's a quality. Not a quantity, it's a quality. Okay. So we'll come back and look at these some more here, but let me just go through the rest of the list. Those first two deal with just substances as they are by themselves. The other is like relation. Relation, cause and effect is a relation between two substances, for example, or between two things. Father and son, that's a relation of this kind. Then we have action and reception, not action and reaction, action and reception. For something to act, there has to be something receiving. For me to teach, you have to learn. If you're not learning, I'm not really teaching, right? So anything, if I push, there has to be something that receives the push. So there's a receiver. And these things, two things go together like the two sides of a coin. You can't have them separate from each other. Okay. Reaction is like another action. It's a back action. So when I push on this, it's also pushing back on me because it's maintaining its own integrity. It's not letting me invade it where it is. So there's another action coming back. So a reaction is another action or kind of a back action. Okay, place, that's easy. Orientation, I'm facing south. I'm lying down. Environment is all the stuff in the room around me, the air, the floor, y'all. Okay, that's all part of my environment. Time. Time is a property of physical things. It's not a separate substance. It does not exist on its own. It exists as a property of physical things. Time reveals to us that change has occurred. Okay. Really simple, right? Don't get caught up in making it complicated. So the two distinctions between the first two, quantity and quality. Quantity has amounts. I can take quantities and make a bigger quantity. I can, and all quantity can be made up of smaller quantities put together. Qualities are mode or manner of existence. So quantity is length, area, volume, having parts. Don't measure it yet. Just it's got those aspects. Okay. If I take two rulers and put them together, I get a longer thing. If I take two red things and put them together, I don't get a redder thing. I just get greater quantity of a red thing. I get more red. Quantity amounts. 1,000 mediocre physicists don't make an Einstein. Doesn't work that way. Qualities don't amount like that. You can't, doesn't do it. Okay? Okay, so this is all on the handout you're going to read. Okay.
So quantity is amount and quality is scale.
Yes.
So what about like density. If you take two things that are of the same density, you don't get something that's more dense.
Right. Density is a mixture of things. It's not self prime.
And it's mass and volume.
Right. So really, let's talk about mass and volume. So we'll get to mass, but volume is quantity. We'll get to mass here. It's coming. Okay. So hold that thought. Okay, but before we get to that, we got to understand something. I'm going to pull off the answer here. What is math? Here's another what is question. We haven't even got to the one I asked earlier. We're going to get there. What is momentum and impetus? But what is math? M-A-T-H. What is it? Again, if you have to remember this from the spring, don't answer.
The physical interpretation of the real world, how things go.
Okay.
It's a set of logical processes that start from something, grow towards something bigger.
You're talking systems again. Systems, yeah. Quality of numbers. Quality with the number. Is it a physical thing? Is number a physical thing?
It's the quality of quantity.
You're getting form.
Didn't you earlier say it?
Math comes from physics, and here's how it comes from physics. But isn't that weird? How many years of math have you had?
Too many, I don't know.
And you can't answer the question? What have you been studying all this time?
I wish I knew.
It has something to do with quantity. Math is the study of quantity as such. That's math. Extension and parts. Let me demonstrate to you. I have parts. I got lots of parts. So here's a part that's kind of like that part. I've got 2, 3, 4, 5. You explain to anybody what a number is. What do? You use your fingers. You use the quantity, which is a substance with parts. That's number. A whole with parts, that's number. What's the other aspect of quantity? It's the shape, the boundary. Now that's not quantity per se, it's quality. But it's a quality that's closely related to quantity, the shape. Why is it not quantity itself? Because I can have 2 triangles that have the same shape but different size. Put 2 triangles together, I don't get more triangles, right? The shapes don't work that way. So math, in its basics, in its primitive origins, is the study of quantity, which is the base property of physical things. If you want to show somebody that 3 times 2 is the same as 2 times 3, what do? You lay stuff out on the table and group them. You do physical things. So math has become very symbolic and abstract, but its origin is deep in the nature of physical things, which is what we understand. So that's why math has something to do with physics, because it's the study of the base property of physical things. So it's no surprise maybe that math has got something to do with physics. Okay, now you understand for the first time in your life what math is. Isn't that amazing?
So it isn't just
So we develop it into a system, right? We develop it into a system, but that's not where it begins. You learn about the quantitative nature of things. The physical things have quantity as their base property. And that teaches you, and from that you learn about number and shape. Shape becomes the study of geometry. And number becomes arithmetic, which evolves over time. We develop into symbolic system of algebra and calculus. But all that takes time, and it's not obvious when you're up here learning this stuff at the high level where you started. But it's a little bit like being out on the beach. To say that math doesn't come from physics is like standing on the beach and taking a branch to erase your footprints. Right? You're just going to pretend I started here. I didn't walk first anywhere, but that's not how it works. Math comes from your understanding of the physical world and this very basic aspect of physical things that they all have quantity as their base property. Okay, so I've used up my time for today, and I haven't even gotten to impetus yet and momentum, so I'll do that for you on Friday. So you learn about momentum and impetus and the cause of motion. So see you on Friday.